All right, and we're live. This is going to be the reciprocal trig homework help video. Right as we get started here, I want to remind us all what ratios are represented by the operations cosecant, secant, and cotangent. So if I take the cosecant of an angle, so CSC of theta, cosecant is the opposite of sine. Sine is opposite over hypotenuse, so cosecant is going to be hypotenuse over opposite. Secant of theta is the opposite of cosine. That's going to be hypotenuse over adjacent. And cotangent of theta, that's the opposite of tangent, which is going to be adjacent over opposite. Definitely want to include these onto a note card if you can't remember the ratios off the top of your head. The big one is cosecant and secant really should be flipped. It would be so much easier to remember, but that's the way it is. So we got to remember that it's not the way that you would do it if you were doing it intuitively. All right, let's look at the angle in number 1 here. We've rotated our terminal side around until it landed right here at 13 pi over 6. And I'm going to go ahead and I'm going to say that this interior angle here has got to be 30 degrees. Now, I know this for a couple of reasons. One is that I've got a radian measure that's over 6. So when it's over 6, you've got two options. It's either going to be a 60 degree or a 30 degree. And then I sort of just look at the picture. The picture isn't drawn precisely, but it's drawn well enough for me to tell that this is the more narrow angle of 30 degrees, leaving the 60 degree angle over here, a much wider angle. Now, if we wanted to really double check that, we could maybe convert this into degrees and then subtract 360. But since we know it's got to be one of three angles, 60, 45, or 30, we can just do it by sight pretty well and then just double check with, well, does that make sense with the radian measure we're seeing up here? All right, time to label this. 30, 60, 90 triangles are all similar. So we can label it with the known side lengths of a 30-60 triangle that we've memorized. And those side lengths go 1, 2, and the square root of 3. I am asking that you go ahead and memorize those side lengths. This 2 is always measured from the middle out, so the hypotenuse is always positive. But the legs are measured in a way that if we ever go left or down, the length is actually a negative length. So this square root of 3 is positive. If I go from the origin to this point on my terminal side, I would go to the right, making that square root of 3 positive, but then I would go down, making this a negative 1. Let's label all of our side lengths with the correct words. My interior angle here is always my important angle. Sometimes we call that theta. Looking out from theta, this would make this side over here the opposite, this side length over here the adjacent, and this side length over here the hypotenuse. Now we're ready to look at our problem. We're asking for the cotangent of theta. So, and theta being negative 13 pi over 6. So the cotangent of negative 13 pi over 6 is equal to, I look over here, adjacent over opposite, which is equal to the square root of 3 divided by negative 1. That simplifies to negative square root of 3. And I'm curious if in the answer key, yeah, they leave it in the square root form. All right, let's look at number 2. I want to construct a right triangle there so that I can have an opposite, an adjacent, and a hypotenuse, but it's right along this y-axis, making it kind of difficult to construct a right triangle. So what I do is I put my terminal side just a little bit off of the right axis, or of the y-axis, so that I can still drop a point to my x-axis, making a right triangle. But then to make sure that this line is actually lining up here, I make this length here equal to 0 units. The hypotenuse, always positive, is 1. The opposite here is going to be negative 1, though, because it went down from the x-axis. Let's label this up. We got the opposite here, the adjacent here, the hypotenuse here. Now we got secant So the secant of negative 90 degrees is equal to hypotenuse over adjacent. The hypotenuse is 1, the adjacent is 0, so this equals 1 divided by 0, which we know to be undefined. We can't divide anything by 0. All right. Let's do one more, and then we'll go over how to double check these in the calculator. Cotangent. Another one, exactly like the one above it, where that's a 30, 60, 90, making this 1, 2, and the square root of 3. Make that a negative 1. Label this up as the op, jace, hype. Cotangent is a over o. So square root of 3 divided by negative 1 equals negative square root of 3. Okay, well, let's go over how to double check that one in the calculator. You'll notice there is no cotangent button on the calculator. So how do we plug it in? If I want to double check that I got this one right, the cotangent of 690 degrees. Well, if I want to plug in cotangent to the calculator, I've got to do 1 divided by tangent. Now I'm going to enter 690 degrees, but before I press enter, I'm going to make sure I'm in degree mode. Switch that there to degree mode. Plug it in. I get negative 1.73. How do I know that that's the same as my answer? Well, I have to plug my answer in as well. Negative square root of 3. And look at that, I get the same answer. All right, let's do one more. How about this one here? This is clearly a 45-degree angle. We can tell, especially because that angle measurement ends in a 5. The only way that that's possible is if that interior angle is 45. So 45, 45, 90, giving us the side lengths 1, 1, and the square root of 2. Except we're going to make that a negative 1 because we're going down. Oh, I'm going to make this a negative 1 as well. Secant is hypotenuse over adjacent, so the square root of 2 over negative 1, which equals negative root 2. Double check that one if you want. All right, I've got a point on my terminal side. I want to find the trig function indicated. The coordinates of that point give me 2 of the side lengths of the right triangle that this makes. So if I drop the line down here to make a right triangle, the y value would be the height of that triangle. The x value would be the base. Cosecant, that's going to require that I know the hypotenuse. So I'm going to do the Pythagorean theorem real quick to calculate for the hypotenuse. Let's see, I got 100 plus 400 equals c squared, 500 equals c squared, square root. I can split that into the square root of 5 times the square root of 100 equals c, or I should have done that the other way around, but 10 root 5 equals c. All right, so that's 10 root 5. Cosecant is hypotenuse over opposite. This is the opposite. This is the hypotenuse. Hypotenuse over opposite will be 10 over root 5 divided by 20. Divide the top and the bottom by 10, and I'll get the square root of 5 over 2. Let me see if that one matches up to our answer key. Square root of 5 over 2. Yep, there it is. Yeah, so that's how, if I was doing this homework, I'd be double checking these as I go, making sure you're doing it right. Those are good. Let's just do one of these last problems, and we'll call it good for this video. Describe all of the transformations necessary to transform the parent function, which could be either sine x, cosine x, or tangent x, into the given equation, then sketch a graph using radians. I would say of these 4, Number 13 maybe looks like the most tricky. So what do we got here? This 1/2 tells us the amplitude. The amplitude is 1/2 unit. This theta divided by 4, well, I could rewrite that slightly as 1/4 times theta, giving me a b value of 1/4. My h value, I've got to flip the sign to get negative 2 pi over 3. And my k value equals -1. So what's nifty about the k value is that this is my midline, and it's also the vertical shift. Amplitude is just equal to 1/2. Now b and h kind of work together to tell us two pieces of information. One is that the period is always equal to 2 pi divided by b, so 2 pi over 1/4. If I copy dot flop that, I'm going to get 8 pi for my period. And for the horizontal shift, also known as phase shift, I'll write it down over here, phase shift, that's always equal to h over b, which is equal to -2 pi over 3 divided by 1/4. Copy dot flop that, and we'll get -8 pi over 3. So that's left. Okay, it's time to now graph this. The first thing I'm going to do is I'm going to sketch in what our parent function cosine of x looks like. It starts at a peak of 1, and then, 1 second, I've got this actually drawn wrong. By the time we get back to 2 pi, it's completed a full cycle. That makes this zigzag line. And I'll do my best to make a curve to hit these points. All right, let's see. It needs to move, everything needs to move 1 point down. So let's just move our first wave 1 point down. The period needs to become 8 pi. So that last touch right there. So instead of going from 0 to 2 pi, now it's going to go 0 to 8 pi, hitting a minimum at 4, halfway in between at 6 and 2. Just get rid of these dots. Okay, so I've applied 2 shifts there. The vertical shift and the period shift. Now it's time to phase shift this. And then I think we're done. It needs to move left 8 pi over 3, which is, it's about 3 pi. It's a little less than 3 pi, so we're just going to move everything a little less than 3 pi. 2, 3, a little bit less. 1, 2, 3, a little bit less. And final graph. Oh, we have yet to shift the amplitude. Whoops. Okay, so the final graph will have a much narrower amplitude, just kind of a wavy line right in here. Oh, not perfect. I bet you can do a better job than that. Hopefully you got the gist of it. You got to apply these shifts one at a time. Let's just see if I got anything close to what number 13 looks like. Yeah, wavy line, low amplitude. It's been faced down and it's been stretched out. That's good enough that from my little sketch, you'd be able to pick out the right one from a multiple choice. All right, so that's it for this video. Have a good rest of your day.